So we live in a very complex and interconnected world. Now what's interesting is we're actually collecting more data than ever before on this very complex world. But the real question is, as humans, what do we do with this complex world? And the answer is, not a whole lot without technology to help us make sense of the world. So the good news is that we're collecting all this data, but for everyone in the room who's in technology, this is a huge headache. But the good news is that the solutions are actually in the data themselves. My name's Huston Hedinger, and I work with a very old technology called graphs, but I'm going to tell you for the rest of the time tonight about graph databases, a very new and emerging technology. So first, let's talk a little bit about the data science and the statistics that we've inherited from the 20th century. So antiquated data science and statistics allow us to take some raw sample of data, and if we can test the data and make sure that it's random, we can then make some crude assumption about the data and then glean some insight. But the challenge is that this leaves us with a very simple worldview. And ultimately, this is the thinking that actually underlies many marketing technologies today, even some medical research, and even some search engines, like Bing. Just kidding. But the reality is that with graphs, you take a much different look at the raw data. You actually assume the opposite. You assume that the data is richly interconnected. And you structure that data based on the connections inherent in the data. And what this ultimately means is that we end up with a technology and a data set that actually mirrors the complexity of the real world. Think about the social network in this very room. Think about traffic networks. Friends influence you. In a traffic network, bottlenecks cause traffic. This is the real world. And so here are the early adopters. Google's knowledge graph is going to change the way that we grab information online forever. And Facebook's graph search is extending word of mouth like you can't believe. So for the next few minutes, we're going to talk about how Facebook is actually using the graph for their search. And this is one of the exciting things about the graph data models. You can actually draw it very easily. So typically you go from whiteboard conversations straight to engineering your database applications. But every graph query starts with a user in the middle. And when you're asking a graph search query, you ask a question like, show me the best restaurants in New York. And what you have are your friends and your friendships, but what you also have is that your friends are connected to these other things like fan pages or restaurants. So when you ask that question, what you get are the most endorsed restaurants, but according to your network. So everyone in here can ask the same question about best restaurants in New York, but we'll all get very different answers based on our personal social networks. Now, the reason that graphs can do this is because that graphs are actually indexed based on relationships. So they have rapid query times for connected data sets and lookups within those connected data sets. And in case you're wondering, the social graph is actually very, very big. That's Mark Zuckerberg, in case you're wondering the other question. But graphs are actually everywhere. And graphs can be all sorts of different things. We're currently working with a hospital, and a hospital has 20 years of data that they have across a number of different, and it's human genomic data, across a number of different data sets. And every time they do a research design, they actually design a new database with a new schema. Now, this is a huge amount of overhead. And what we're able to do is we're actually able to consolidate all this data into a single graph. And we add to the genomic data actually patient outcomes. And this is offering new insights. So now that we have the data in a single graph, then we can actually build a graph infrastructure that allows them to do all their research, or build all their applications off of a single database. You can also build rich visualization applications that allow them to see patterns and information that they couldn't see any other way. So when you have proteins interacting in a cell, the large circles actually will skip to the Hollywood network. This is the good one. So here, you can see how actors collaborate on movies, and you can ask with a graph those important questions like how Kevin Bacon is connected to Johnny Depp, for instance. So graphs have an advantage because everything is truly connected, and graphs actually model the complexity of the real world. And that's what we think is amazing. This emerging technology, however, we're all learning together. And so we're excited to start the PDX Graph Meetup. I challenge you guys all to attend. We'd love to have you. And definitely reach out. If I can help you point in the right direction with your graph research, I'd love to. And I look forward to seeing what you guys build with the graph. Thank you.